to the first sum. Now these are 5-mark sums. Question number 1. Cot inverse of half minus half of cot inverse of 4 by 3. Now here we have proved that is equal to pi by 4. Now how to do that? First of all, as I have told you always, the first thing is that here if you see it is half. Half means it is positive number. Here also it is 4 by 3. That means it's also a positive number. So in these cases, if you want to convert to tan, you can do that very easily. But here what we do, you see, I write here is cot inverse of half x pi by minus tan inverse of minus what we have, half of cot inverse of 4 by 3. Now pi by 2 minus, I take half common. If I take half common, it is becoming what? 2 tan inverse of half plus cot inverse of 4 by 3. Minus has been taken common. I am taking the whole thing within the bracket. So this is 2 tan inverse of half plus cot inverse of 4 by 3. Now from this, what we can write? Pi by 2 minus half of. Now here 2 tan inverse of half. We can apply here the formula. When x is here, what is the x? X is this one. So what is the formula you know? 2 tan inverse of x equal to tan inverse of 2x by 1 minus x squared. Now when we can apply this formula? When x is less than 1, greater than minus 1. And here you have half, and half you know obviously less than 1 and it's greater than minus 1 also. So in this range you can apply this formula. So what we get here? Tan inverse of 2 into half by 1 minus half square plus cot inverse of 4 by 3. Now this gives us pi by 2 minus half of tan inverse of 3 by 2 plus cot inverse of tan inverse of 4 by 3 plus cot inverse of 4 by 3. So just to simplify this 1. This is 1 minus 1 by 4. So denominator we have 3 by 4. So it will be argument to 4 by 3. Now this gives us what? Pi by 2 minus half of pi. Why pi by 2? All of you know that tan inverse of x plus cot inverse of x equal to pi by 2 when x belongs to 1. So here this one is a real number, this one is a real number. So this sum will be pi by 2 and we get here what? Half of pi by 2. There is pi by 2. Now if we simplify this, we get pi by 6. From the beginning, it is cot inverse of half minus half of cot inverse of 4 by 2. So cot inverse of half, what is by 2 minus tan inverse of half minus half of cot inverse of 4 by 2. Pi by 2 minus 2. Why is half is taken common? This will be 2 into tan inverse of half plus cot inverse of 4 by 2. 2 tan inverse of x formula will you know tan inverse of 2 is by 1 minus x squared. So that is been applied here. And we can apply that why? Because the x which we have here is less than 1 but greater than minus 1. Now we got this, this is a real number, we can apply this formula. Okay. Another way out is of solving this problem is this also. Sometimes you can do it that way directly also. That is, suppose here you are converting to tan inverse, here also, and then you are solving. Here also you can do, or you can do this. Next. We move on to question number 2. Sine inverse of 12 by 30 plus cos inverse of 4 by 5 plus sine inverse of 63 by 60. Now, so tan inverse of 63 by 60. So in this case, what we'll do, since we have done all the three formulas based on the tan, it will be easy for us if we convert it to tan. Now here the plus point is all these numbers are positive. In this sum, is a benefit for us. All are positive, so you can easily convert to this to tan. For example, first one, sine inverse of 12 by 30. You can think in this sum. And this is suppose some theta. So this is some 12k, this is some 30k, and this will be 5. K not equal to 0. So here what we have, sine theta equal to 12 by 30. So here tan theta will be 12 by 5. Similarly, we can take the other one, cos inverse of 4 by 5. So this one, we take another triangle. This is suppose alpha. So cos inverse of 4 by 5, that means this is 4k1 suppose. This is 5k1 and this is 3k1. K1 not equal to 0. Now, here what we can do, it is tan inverse of 12 by 30. So that will be tan inverse of sine inverse of 12 by 30. So tan inverse of 12 by 5. Plus next one, we can convert again by using this one. This triangle, that is cos alpha is what here? 4 by 5. And from that you can find tan alpha. What is tan alpha? Tan alpha is here 3 by 4. So this one is giving us tan inverse of 3 by 4 plus tan inverse of 63 by 60. Now, we will apply here tan inverse of x plus tan inverse of y formula. So what we get here, tan inverse of 12 by 5 plus 3 by 4 divided by 1 minus 12 by 5 into 3 by 4 plus tan inverse of 63 by 60. Now, this one, if we observe carefully, these two numbers, both the numbers are positive. That is, if you take this one as x, this one as y, both are positive. Okay. So here the first observation is 12 by 5, comma 3 by 4 greater than 0. Now what is the product? 12 by 5 into 3 by 4 is greater than 1. 36 would be obviously greater than 1. Now, according to the formula, you know the tan inverse of x plus tan inverse of y. What do you write? Tan inverse of x plus y by 1 minus xy plus 5. Why you write plus 5? When x is greater than 0, x and y both greater than 0, and xy is greater than 1. So there will be a plus 5. Now, if we simplify this, what we do? 5 plus tan inverse of 63 by minus 16. So minus 63 by 16 plus tan inverse of 63 by 16. Now this is a negative number. This is a negative number. All of us know the tan inverse of minus x is what? Minus tan inverse of x. So here what we write? 5 minus tan inverse of 63 by 16 plus tan inverse of 63 by 16. And that gives us what? 1. Now we move on to next one. 2 cot inverse of 5 plus cot inverse of 7 plus 2 cot inverse of 8, and you have to find the value of this one, which is 5 by 4. You have to prove this one. Now, here what we can do, at first, we'll bring everything in terms of 10. We'll convert here everything in terms of 10. Why into everything in terms of 10? Because we are familiar with the formula of the 10 function. So 10 inverse function of 10. Now here the plus point is again, all the numbers are here positive. 5, 7, 8, all of them are positive. Now if all of them are positive, what we can write 2 10 inverse of 1 by 5 plus 14 inverse of 1 by 7, 10 inverse of 1 by 7, 10 inverse of 1 by 7 plus 2 10 inverse of 1 by 8. Now since both of them have 2, we can take this common and open it. So 2 tan inverse of 1 by 5 plus tan inverse of 1 by 8 plus tan inverse of 1 by 7. Now this 2, this one will take as x, this one as y. So here what we can say, tan inverse of x plus y by 1 minus 6y. Now here you see, there is no addition of pi. Why not? Or suppression of pi. Why not? Here x and y product is less than 1. So here what you observe, that xy product is less than 1, because that is applicable for anything, that is both positive, both negative, one positive, one negative, one negative, one positive. So everything we can apply. Just you have to see this one, that xy is less than 1. Now here tan inverse of 1 by 7. Now if you simplify this to tan inverse of 5 plus 8 by 40 whole divided by 40 minus 1 by 4 plus tan inverse of 1 by 7. Now this is reducing to 2 tan inverse of 13 by 39 plus tan inverse of 1 by 7. 13 by 39 means what? 1 by 3. Now this number, okay, let us simplify this one. It's 2 tan inverse of 1 by 3 plus tan inverse of 1 by 7. Now this number 1 by 3 is definitely lying between minus 1 and 1. This 1 by 3 is lying between minus 1 and 1. So you can apply the formula. Which formula? 2 tan inverse of x equal to tan inverse of 3 by 1 minus x square when x is lying between minus 1 and 1. So here we can write this one as tan inverse of 2 by 3 by 1 minus 1 by 9. Tan inverse of 1 by 7. Now this will be what? If we simplify this, 9 minus 1, 8, and here it will be multiplied, so 6 by 8. 6 by 8 means 3 by 4. So this gives us tan inverse of 3 by 4 plus tan inverse of 1 by 7. Now here we can apply the formula again. Even you can apply the formula of tan inverse of x plus tan inverse of 1. So we'll apply the formula here, tan inverse of x plus tan inverse of 1. So here we get tan inverse of 3 by 4 plus 1 by 7 by 1 minus 3 by 4 into 1 by 7. Here 3 by 4 into 1 by 7 less than 1. So tan inverse of 21 plus 3 plus 4 by 28 minus 3. So that is tan inverse of 1 is 5. See from the beginning. What we have done? We have converted here this one to tan first. Why? Here, why should we do this? Because here x is greater than 0. When x is greater than 0, cot inverse of x is what? Tan inverse of 1 by x. So we have done exactly that. 2 tan inverse of 5, we have written 2 tan inverse of 1 by 5 because x is greater than 0. Tan inverse of 1 by 7 plus 2 tan inverse of 1 by 5. These two have taken together. Tan inverse of 1 by 5. 7 is separate. Now 2 tan inverse of 1 by 5 plus 1 by 8 by 1 minus this one. Here xo is less than 1. So you have applied the formula. Simplify. After simplification, again 2 tan inverse of x formula. We can apply here this formula because x is less than 1. This formula. Because x was less than 1 but then minus 1. And then tan inverse of 3 by 4 plus tan inverse of 1 by 7. Again, we have applied the formula. We got the answer. Next, we come to question number 4. Four tan inverse of 1 by 5. Now we come to this one. 4 tan inverse of 1 by 5 minus tan inverse of 2 by 30. Now here what we'll do? 2 into 2 tan inverse of 1 by 5 minus tan inverse of 1 by 239. Okay. 2 tan inverse of 2 into 2 tan inverse of 1 by 5. Now this value is x. Now here what we understand? X here is less than 1 greater than minus 1. So here 2 tan inverse of x formula is what? Tan inverse of 2x by 1 minus x squared. So here we apply that. 2 into tan inverse of 2 by 5 by 1 minus x squared minus tan inverse of 1 by 239. So this gives us what? 2 tan inverse of 5 by 12 minus tan inverse of 1 by 239. Why 5 by 12? 2 by 5, here 1 by 5 square. 5 square 25, 25 minus 1, 24. Here what we get? 10. So cancel out. 10 and 24, 5 by 12. Now here we apply the formula again, this formula. Here you see, this number is 6. Now this number is less than 1, greater than minus 1. So here again, we apply the same formula. So this will be what? Tan inverse of 2 into 5 by 12 by 1 minus 5 by 12 whole square minus tan inverse of 1 by 239. Now this gives us what? Tan inverse of 5 by 6 by 1 minus 25 by 144 minus tan inverse of 1 by 239. Now this on simplification what we get? Tan inverse of, if we simplify 144 minus 25, that is 119, and this will go in the numerator when we get 120. If here 6 is getting cancelled out, it is 144. Suppose 12 is what? 144. And here it will be 5 by 6 into 144, it will be 120. Yes. Because it is 12 into 24, 25. So it is 24 into 5, that is 120 by 190 minus tan inverse of 1 by 230. Okay, what we have here? Tan inverse of 1 by 230. Now, 239. And here what we have? 190, 120 and 190. Okay. Now, if we add these two numbers, we get 239. Now, how can I make this two number add in the denominator? See, if we subtract tan inverse of 1 and add here a tan inverse of 1. If you subtract, if you operate the formula here, what do you see? Tan inverse of 120 by 190 minus 1 by 1 plus 120 by 190 into 1 minus tan inverse of 1 by 239 plus pi by 4. So this will give us what? Tan inverse of 1 by 239. This you can answer easily. 120 minus 191, 120 plus 192 minus tan inverse of 1 by 230 plus pi by 5. The sum is easy. Just this technique is important. We come to question number 5. Tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3. Here, tan inverse of 1 means pi by 4. This one, tan inverse of 2 plus 3 by 1 minus 2 into 3. Now here, what I have done? I have applied here tan inverse of x plus tan inverse of y formula. But here x and y both are positive. Here x and y both are positive. That is 2 comma 3 greater than 0 and 2 into 3 greater than 1. So plus pi. Now here pi by 4 plus tan inverse of 5 by minus 1 plus pi. Now here it is pi by 4 minus tan inverse of 1 plus pi. So you know tan inverse of 1 is what? Pi by 4 only. So minus pi by 4 plus pi. What we get? Pi. So this is the first part of this sum when we get it as pi. Now we come to the other part. We have 2 into tan inverse of 1 by 2 plus tan inverse of 1 by 3 plus tan inverse of 1. Now tan inverse of 1, that will be pi by 4. So here 2 outside, pi by 4 plus, because of tan inverse of 1, I have written pi by 4. Now here you can apply tan inverse of x plus tan inverse of y formula. By 1 minus 1 by 2 into 1 by 3. Now here you can see x and y both are positive. That is half and 1 by 3 greater than 0. Now half into 1 by 3 is greater than 0 but less than 1. This is half into 1 by 6 is greater than 0 less than 1. Or you can directly write here that 1 by 2 into 1 by 3, only this also you can write. That's enough, more than enough, because the condition is x has to be less than 1. We have this tan inverse of x plus tan inverse of y. We can write as tan inverse of x plus y by 1 minus xy when we can write. When xy is less than 1. Further, we don't need this to be greater than 0 or less than 0. Anything it can. Just we have to be saying that this condition is satisfied or not, that xy is less than 1 or so xy is less than 1. After that, you have this greater than 0 or less than 0, that is immaterial. Only xy has to be less than 1. Now, here what is 2 into pi by 4 plus tan inverse 1. Now, here 2 into, here is pi by 4, tan inverse of 1 is pi by 4. So it is pi by 4 plus pi by 4, and that is 5. Because it's pi by 2 into 2, that is 5. Next, question number 6. Three tan inverse of 1 by 2 plus root minus tan inverse of half. Now we can simplify this one. 3 tan inverse of, if we rationalize this one by multiplying 2 minus root in the numerator denominator, what will get? In numerator we will get 2 minus root 3 only, and this will be reduced to 4 minus 3, that is 1. So ultimately what we get? 2 minus root 3 minus tan inverse of half. Now this gives us what? What is the value of this one? 2 minus root 3, pi by 2. So this one we can write 3 into pi by 2 minus tan inverse of half. So this gives us pi by 4 minus tan inverse of half. Now pi by 4 we can write tan inverse of 1 minus tan inverse of half. Now here we can apply the formula again. So what we can write? Tan inverse of 1 minus half by 1 plus 1 into half. Now here also we observe that 1 into half is less than 1. So we can apply this formula, no problem. So that gives us what? Tan inverse of half by 3 by 2. So that gives us what? Tan inverse of 1 by 3.